Go. Hello, hello. Today we are going to be studying a little bit about Stardog and their implementation of semantic graphs. Um, yeah, so these are knowledge graphs, making sense of data. Um, yeah, hello. Um, I guess my objective today is just to understand Stardog a little bit more because I was able to set it up. I was able to hook it up with a database running on my own AWS system. But I want to be able to see how it all makes sense. So we're just gonna be watching it together and see what we can learn from it. hmm so yeah, let's just go ahead and watch it. Um, there we go. We can probably start at the very beginning. I can leave the link to this video. Is this one? It's titled "Getting Started with Virtual Graphs," published by Stardog 3 years ago. So let's see.
Okay, so let me start by introducing myself. My name is Hasura. I'm a co-founder and the chief scientist of Stardog. I've been working on knowledge graphs and semantic technologies since early 2000s and participated in the standardization efforts for these technologies over the years as well. So today in this training, I will talk about how to map relational data to RDF graphs. The R2ML specification developed by W3C is a mapping language for doing this. We'll start with discussing what conceptual mapping is and then go over the syntax of the mappings and see how we can query data stored in a relational system using Sparkle. At the end, I will briefly discuss how to map NoSQL data sources like MongoDB and Cassandra into RDF as well. So before we get into the technical details, I'll spend just a few minutes to give you a high-level motivation for virtual graphs. I'll talk about the mappings, show a demo of how to use those mappings. At the end, I'll try to answer as many questions as possible. So for the motivation, I'd like to talk about what we think is the most important problem knowledge graphs address, the data side of problem in the enterprise. As most of you know, organizations have been built to manage data by department and type. These data sources are disconnected from each other and can be used within the context of the department or the application that generated them. But most strategic questions in the enterprise can be answered only when you have a unified view over all the different data sources. And that's where we can use virtual graphs to connect data from multiple sources without moving or copying it. So a virtual graph exposes structured or semi-structured data as a graph using declarative mappings while leaving the data in place. And when all the data sources of interest are represented in our knowledge graph, we can easily connect nodes from different sources and create a unified view over all the data.
Okay, I want to pause a little bit here. Understand the graph. Works with existing infrastructure for databases, uh, business intelligence, and analytics. Stardog is delivered on premise or on the cloud based on a reusable data model capable of working across different schemas and standards based. It is not just a data visualization tool. It is not just a storage only. It is not a storage only database. So it's okay. So it's not a visualization tool. Okay, interesting. So you have your structured data, semi-structured, and unstructured data. Then you have your ingest, which is basically how you input it into the Stardog ecosystem. I was able to tinker around with this. I was able to connect a Postgres a while ago. Then it has a graph database for AI and machine learning query engine, right? It has a reasoning engine. The declarative model I don't understand completely yet. I'm not entirely sure how they model it declaratively. I'm talking about like the data, because the data would be coming from different sources, right? Postgre, MySQL. So I'm curious about how they were able to like how they defined the declarative model. But definitely it was because they talked a lot, right? They talked a lot and they came up with standards, and that's how they were able to produce this enterprise knowledge graph kind of system. And then when they were able to put that graph database together, make sense of all of the multiple things, then those information can be accessed on top of that layer, services layer, and then enterprise applications can be built on top of it. So the reason why we're studying this right now is because I intend to use knowledge graphs for tome.gg, right? So let's keep going.
In Stardog, we use this kind of unified view to to connect the data sources and then provide tasks like business analytics, machine learning, and more over the knowledge graph. At this point, let me mention that the material that I will cover today, all the data files, mappings, queries are available. You can go to the tutorial.
Let's see if those links are still alive. stardog.com/tutorials. Because I'm already like tinkering with them in other parts. What I want to find, I guess, is being able to use virtual graphs from an existing Postgre database. So maybe this is the tutorial relevant to me. Learn how to write mappings that map relational data, right? Or Postgre data to the knowledge graph. In this tutorial, we'll learn how to create a virtual graph in Stardog using this map and how to query the virtual graph using Sparkle. Yeah, so I was able to do this already. I'm just not entirely sure where it was. I think it was here, maybe? No, here. No, here. No, here? Where is it? This one? No, not this one, not this one. This one, not this one. I can leave that one open. It's this one, right? So we were able to tinker a little bit. We were able to connect the Postgre database here. But I don't really know what's next. Maybe let's just watch. Let's just watch. Don't have to overstress it.
Tutorials page on our website for the details of virtual graphs and RDF, Sparkle, and other features of Stardog as well. And there's a GitHub repository linked from the tutorials where you can find the actual data files. So in this webinar, we are assuming that you are familiar with the basics of the RDF model. If not, you can go check out the tutorials page that I mentioned. But I'll quickly...
I forgot what RDF means. I think it's data format. I don't know what RDF means. Resource description framework, I see. It's a standard for as a data model for metadata, right? It's those colon something, right? Colon name, colon member of, right? It's how you define properties and metadata. So you can have metadata about metadata if you want to.
Do a recap of the RDF terminology, at least to refresh your memory. So RDF has a special vocabulary to refer to the nodes and the edges in a graph. An edge is called a triple because it has 3 components. The source node of the edge is called the subject. The target node is called the object. And then the edge identifier for the relationship between those 2 nodes is called the predicate. So the identifiers used for predicates are called properties. So in this example, member is a property that's used in the predicate position of the triple we see here. And an RDF graph is defined to be a set of triples, which can be visualized as nodes and edges, as we see here. Okay, there are 3 different kinds of RDF terms. There are IRIs, which are nodes that have unique identifiers. IRIs are also used to identify the predicates as well. The nodes that represent primitive values like numbers and dates are called literals. And there are also blank nodes, which are nodes without an explicit identifier. But we won't talk about them too much today. Okay, so we'll have a running example in this webinar, which is inspired by the Open Music Encyclopedia, MusicBrainz. MusicBrainz collects and stores music metadata in a relational database and makes it available to the public. The database schema for MusicBrainz is quite complex and not suitable for this webinar. So we are going to use this simplified schema that we see here. But if you are interested in more complex examples, there's actually an open source project called LinkedBrainz that provides the complete mappings for the MusicBrainz database. So you can find that link in the tutorials page as well. So in the simplified schema that we are looking at, we have one table for artists, one table for the albums that the artists released, and there's another table for songs, the tracks in those albums. Tables have columns for attributes such as names and descriptions, and there are also some foreign key constraints as shown by the lines connecting the tables in the schema. So looking at this diagram, it's kind of obvious that the schema is conceptually representing a graph, and the foreign key constraints are hinting us what kind of connections we have in the graph. And in the R2RML specification, there's actually a description of how you can take a relational schema like this and automatically create the mappings for a default RDF schema based on the primary and foreign key definitions in the schema. And this default mappings might be an easy way to get started, but most of the time we want to map the relational schema to an existing RDF schema.
So just to try to see if I can still read these kinds of graphs. The blue ones I think are nodes or concepts. Can't remember. I think it's called concepts in Protege, but I think it's called models in the Stardog lingua. Um, so an album has tracks, and those are called songs, right? A song is a track of an album, and then a song has a certain length, which is some literal. So green ones are literal, XSD. XSD I think is another what do you call it? Prefix. Oh, we skipped everything. Let's just go back here. It's this one. Next, yeah, XSD. XML schema definition, right? Let's go back there.
To an existing RDF schema, a schema that we developed to represent our domain. So in this slide, we are looking at a simplified visualization of an RDF schema for representing the music data, where you can see the similar artist, album, song concepts as in the relational schema. We'll see the details of the schema as we look at the mappings in more detail. So I'm not going to talk about this too much right now. Okay, so we'll first look at kind of the intuition behind the mappings with a graphical example before getting into the syntax of the mappings language. And generally, in the relational model, each table represents one entity type, and rows of the table represent instances of that type. For example, here you see the artist table on the right side of the slide, where the rows are representing different instances of artists. So when we map a table to RDF, typically there's an RDFS class corresponding to the table that we are mapping. In the artist table, we actually have two different types. So we have both solo artists, John Lennon, Paul McCartney, also bands like the Beatles. And the type column is differentiating these different types. But for now, let's kind of ignore that column and just simply assume we'll use the artist class for all the rows. Again, typically in the mappings, there's a RDF property corresponding to each column, and the values of the row become nodes linked to the entity node using that property. So we have the name column in the artist table. It would become a node in the graph. And again, usually the columns that are associated with the foreign key would become IRIs, and other columns would be mapped to literal nodes. So in this case, the name column would be mapped to a string literal in the RDF graph. And the artist node is an IRI, which is constructed using an IRI template. So an IRI template is just like an IRI, but it includes variables that will be replaced with actual values. So the artist IRI template we have here concatenates the local name artist with the ID column of the artist table. So the names inside curly brackets identify the columns of the table. So when this template is instantiated with the values with the ID column, we will get IRIs like artist1, artist2, artist5. The column at the beginning of the IRI indicates that the IRI belongs to the default namespace, which is not shown here. But we would get a fully valid IRI as a result of this template. And the combination of the namespace, the local name artist, and the primary key ID that we are using here ensures that the IRIs we generate will be globally unique, and it won't clash with the other IRIs we generate from other tables, or maybe the IRIs we might get from external data sources, other data sources. So we map the album table in a similar way with one node representing the album instance. Then the name and the release date columns are mapped to literals. And then there's the foreign key here, the artist column, which will be naturally turned into a link in the RDF graph. So for the artist column in the album table, we simply use the same IRI template that we used for artists when we mapped artist table. So as a result, the both nodes created by these mappings will refer to the exact same node, and we will get the links between the nodes created by those two mappings. Okay, then we map the songs, and there's another foreign key reference here. But one difference with respect to this example is the track property in our RDF schema goes from albums to songs with respect to its direction. But here the track table will be generating the song nodes in our RDF model. So this will cause a difference when we are defining our mappings a little bit, and I'll highlight it when we are looking at the actual mappings. And one thing you'll notice here as we are creating all these mappings, the implicit graph structure in the relational model becomes explicit links between the nodes in the RDF graph.
I think by implicit, he's saying that, this song number 1 was written by writer number 1 and writer number 2. So it's kind of implicit, but then from the visualization on the graph, it's very explicit. A certain song is written by someone. Name, album, artist. Yeah.
Okay, finally, we have the songwriter table, which is quite different than the other tables because the rows in this table does not represent an entity. So this is what's known as a junction table, which is a standard way to represent many-to-many relationships in a normalized relational schema. So sometimes they're also called bridge or associative tables as well. You might have heard those names. So in the songwriter table, each row is representing a link between a song and the artist who wrote the song. Of course, for simplicity, we are not differentiating like composer from lyricist and those kind of things. So we are just calling everyone a songwriter. And so if you look at the table here, there's the song identified by ID1, which is La Me Do. And there are two writers for this song, artists with ID1 and 2, that corresponds to John Lennon and Paul McCartney. And so when we map a junction table like this to the graph, what happens is we get a single triple as a result of that mapping. So each row will generate one triple. So like the La Me Do song connected to John Lennon for the first row, and the song connected to Paul McCartney for the second row, and for all the other rows in the table as well. So this is pretty much all the intuition you need to know for these mappings. And what R2ML specification does is kind of formalizes how these mappings would be defined, and how the templates, IRI templates are defined, and the mappings for the primitive values and those kind of things. Of course, this is great to provide a clear semantics for these mappings mean, and also allows interoperability if when you are exchanging mappings between different systems. So R2ML has some vocabulary to refer to the different parts of the mappings. So a triples map is the mapping from one row of a relational table or a SQL query to RDF triples. So what we were looking at with artist table was one triples map, album table was another triples map, and so on. Subject map defines the subject that's shared by all the triples generated from that triples map. So a triples map always has a single subject, and the subject map shows you like the IRI template, like the artist IRI template, album IRI templates that we have seen. And then the additional triples generated by the triples map are defined using what's called as predicate object maps. So basically,
So I was muted. So if I understand that correctly, the subject map basically is the list of all of your tables, right? So that would be your artist, your songs, etc. It's your map of subjects, right? And you can derive that from all of the subjects, distinct subjects on your triples map. And the triples map are basically just rows inside of that table, right? So I have John Lennon as an artist. So there is John Lennon, which is the IRI, is an artist, right? Mm-hmm. Okay.
basically defining the predicates between the subject and the other nodes that are being created, and what predicates are used to connect those nodes. So this is how the R2ML syntax looks like for defining these mappings. So this is the mapping for the album table, and kind of shows the same information that we were looking at in the diagrams before. So you have the input table or the query specified at the beginning, selecting all the rows from album table. Then there's a subject map specifying the IRI template for the subject, and then the different predicates that will be used to map the different columns.
So this is interesting. So this is how they're actually creating that kind of mapping. So if you want to have a certain album, it's referenced under this prefix, right? stardog.com/tutorial/album. And then you just append whatever the ID is. So ID might just be whatever column it might be. It might, if it's in string or text or integer. And then it's just appended at the end. So that's interesting. The subject map is this template, and this is saying that the class is an album. And this is its template for its IRI. Interesting. Predicate object map. So the predicate is called name, and the object map is to, its column is name, date, column is release date, artist, object map is to the template of a certain artist, and then it's some ID. Okay. I'm curious, not completely sure what object map is, not really confident there, but this is basically the list of all the predicates. So you have your list of subjects, list of predicates.
So like the foreign key artist column is mapped with an IRI template, so that becomes an IRI node. The other columns will become literal values, and the types of those literals will be determined by the SQL type of these columns. So the dates become SQL dates become XML schema dates used by RDF, like varchars become string literals, and so on. So in Stardog, we provide a more concise way of writing these mappings that we call Stardog mapping syntax. And this syntax is kind of extends the Sparkle syntax, a little easier to write. But we also support automatically translating the mappings between the SMS syntax and R2ML, so you can kind of go between these two syntaxes if you need to generate R2ML mappings.
Okay, this kind of makes me feel a little giddy because I remember writing languages before for my uh, university classes. So as I understand it, they built a mapping from that complicated verbose kind of way into this one where it is a little cleaner. It does look simpler, easier to read. So okay, so this is what's actually beneath it, because I was seeing this kind of syntax before, but I didn't know that
And
this is what it actually looked like
more concise
underneath
way
it.
of writing text, automatically translating the mappings between the SMS syntax and R2ML. So you can kind of go between these two syntaxes.
SMS Stardog markup system or something. Let me hear.
A little easier to write. And this more concise way of writing these mappings that we call Stardog mapping syntax.
Stardog mapping syntax. Okay, it's not system. Stardog mapping system.
And this syntax is kind of extends the Sparkle syntax, a little easier to write. But we also support automatically translating the mappings between the SMS syntax and R2ML. So you can kind of go between these two syntaxes. If you need to generate R2ML mappings, you can do it automatically by first writing SMS mappings and asking Stardog to export it in the R2ML syntax. And but one advantage of SMS that I'll briefly discuss at the end is you can use it to map non-relational data sources as well, which is not supported by the R2ML specification. Okay, so let's quickly go over these different parts of the SMS mappings. So at the top, we have an optional name that we can define for a mapping. It can be an anonymous mapping too, but you can provide the mapping name. Then there's the input table, which specifies the query that we will use to map to RDF. So in this case, we are again selecting all the rows from the album table. And then in the third part of the mapping, we have the output graph. So this is using Sparkle syntax, where variables are will be instantiated based on the values we get from the relational query and based on the value mappings defined in the next section. So in the var clause, we define these IRI templates. So the ID column, the ID values coming from the SQL query result will be turned into an IRI based on this template. And then we bind the resulting IRI into the album variable. And in the previous section, we see the album variable becomes the subject of these triples. So it's the same kind of information represented in R2ML in a slightly different syntax. And now let's switch to Stardog Studio, which is the IDE we use for interacting with Stardog. So there's a Stardog server running in the background. And in the Studio IDE, I'll show you the complete mappings and then how we can actually use those mappings to run queries. So
just to double check, this is my video. I'm going to put it right here. And then I have Stardog running here, 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 here. There we go. Okay. So I have the studio thing. I have the Postgres. Okay, sure. Let's go.
So first, we need to have a database in Stardog for us to run queries against. But so I created a database here called Webinar. It's an empty database. There are no triples in it because initially all the data will be coming from the relational data sources. And here I have already checked out the Stardog tutorials GitHub repo. So this is the files you'll get from that repo. And there's a okay, first of all, of course, we need to have the relational database for us to map to RDF. So here you'll find the SQL schema, the SQL commands that you can run to create the tables that corresponds to the example we were looking at, so the artist album table. There's also a membership table that I didn't mention explicitly before. So this is a junction table, just like the songwriter, which is linking solo artists to the bands that they are members of, past members. So this, you can run this in your relational system of choice, or the syntax you might need to change a little bit based on whatever system you are using. In this example, I have a MySQL database where populating these tables in your mappings for all the tables written in the Stardog mapping syntax. So let's go over these all the mappings here just to understand what's going on. First, we have the album mapping here, which is the example we were looking at before. Then comes the mapping for the artist table. And as I mentioned, the artist table has the type column, which means and solo artists and bands have different values for that type column. So in our mappings, we want to map the corresponding artist with a different type on the RDF side. So one way to do this is have a mapping to map the generic properties of the artist table, like the name and description. This is the same for solo artists and bands. So we can simply get all the artists and then map those two columns in one mapping. And then we have another mapping where the input query now defines a restriction to say only return the artist rows where the type column is 1. And then in our RDF mapping, we say these nodes generated from these rows will have the type solo artist. And then in the next mapping, we change the query to restrict the type column to value 2, and then associate those nodes with the band type. There are different ways to write these mappings. So instead of writing separate mappings, we could have written a more complex SQL query that would map these integer values for types to the solo artist and band types, for example. That would be another possibility. But yeah, in this example, we used simpler SQL queries to write the mapping.
So let's see what that looks like in our current example. I think we have that under virtual graph, I think. Right. So we have a very simple table under tome.gg. So we have pages and page states, because people can submit pages or people can write pages on Tome, but then it has to go under approval. So that was something that I was building out a few months back. So we have pages, we have page states, and then we have which platform it comes from. Does it come from YouTube, TikTok, or whichever? So if you try to follow what he was saying, then we have this concept or this model called pages, and this would be its SQL query. Select all from this database, this schema, and this table, and then it's mapping its contents into this one, api.stardog.com/pages #attributes. So I think I need to fix this one, because api.stardog.com shouldn't be the primary prefix or the default thing. So I'm gonna go back to tome.gg. It should have namespaces here. Then I'm just gonna get tome and just slap it on here. Then I'm gonna remove this one. Right, and then delete that one. So that's the default tome.gg. There we go. Now we go back to virtual graphs. Go here. It's not updated. Is there a way to refresh it? Regenerate mappings. Yep. It's still following that one. Okay, so I can just, yes, I can. Okay, replace all. Save. There we go. Much better. So now these are tome.gg page states and tome.gg pages and platform types. Okay. So if you read pages, pages have attributes, contents, created at, deleted at, an external reference ID, name, platform, etc. And it does binding, wherein the data type of string to date is a function for the created at, and then it becomes created at date time. Okay. And then the subject is basically some ID, which is this one. So if we actually look at Tome and we look at the pages, this is gonna have to have a pages page, like a website page called pages. But we'll get to that later. But for sure, it has to follow the correct URLs. But we'll get to that. No worries. Okay, let's keep going.
And so for the member mapping and also the songwriter mapping, these are the two junction tables we have in this example. So in both cases, we have a single triple generated from each row of these junction tables. So for the songwriter, it's linking the song to the writer and linking the bands to its members for the membership mapping. And for the song mapping, this looks slightly different from the other ones, because now here we have both some triples with the song as the subject of the triples, with this one additional triple at the end where the subject is the album and the object is the song. So this was the direction thing I mentioned before. There's kind of a mismatch in how the relationships are described in the relational schema with respect to how the directions are defined in our RDF schema. So in the Stardog mapping syntax, we can just take this one table and map it to multiple subjects like this. This is one case where it's slightly different than R2RML, because as I mentioned in R2RML, each triples map needs to have a unique subject. So we have the R2RML translation of these mappings. And if you look at these mappings, you'll see that there's a song mapping that corresponds to the triples with the song subject. And then for the linking the songs to the albums, we create a different triples map in the R2RML syntax. But yeah, as I said, you can write your mappings in this Stardog mapping syntax, and the corresponding R2RML will be generated, even if it needs to split some mappings into multiple triples maps. So this is how the complete mappings look like by clicking this Create Virtual Graph button here, I can register these mappings with my Stardog server by providing some of the, and using Stardog, you can make change, using Studio, you can make changes to these mappings if you wanna rename some of the properties, and then you can just save your changes to update queries against it. So we have some sample queries. I'll start with this example, which is,
Okay, so this is the part that I kind of got stuck, and the reason why I actually started watching on YouTube. So I have it loaded up already, and it does have data because I can check it here, right? I can see that it does have the pages that I have, right? Even test data. So the question is, how do I actually query stuff? How do I actually query stuff? I'm honestly not sure. So let's look at this example. Saying there's a graph, virtual music, there's a band, there's a name, Beatles, right? I'm already at the point where I just want you to show me the names of pages, right? Like, let's keep it extremely simple, extremely lean. Um, Tome.gg. Go. But it's not showing anything. That's the weird part. Um, Store query. We'll call this get pages, right? Okay, get query pages. Okay, then that should show up somewhere here, right? But then there's nothing. Nothing, nada, zero. Why? I'm connected to stonegg.dev but it's not showing anything. Let's see what happens.
Retrieving the band with the name Beatles, finding the members of that band, and then the names of those members. So I will select our empty database webinar, and here in the Sparkle query, we are specifying that these patterns should be answered by the virtual graph named music. So typically in
So I say the graph of which virtual graph? This is called tome-gg-env. Okay, so I would go here and say virtual tome-gg-env dev, I think. That's what he does.
Sparkle, you can use a named graph in the graph clause that will
I completely don't know what the syntax is.
correspond to the graph stored explicitly. But when you use the virtual graph keyword here and execute the query, so first of all, we see that we get the result from the...
I wish that happens. So it does work. Okay. Okay. Content. It doesn't know the content. Let's look at the virtual graph. Does it have a content on the pages? Yes, it does have a content. But does it have content? Yes, it does. Yes, it says text. The question is, why doesn't it show a content? Oh, because I didn't right. Okay, so we need to specify the content, right? This is the property. This is where it gets found. Does this make sense? Does this make sense? I'm not entirely sure. Let's just double check how the virtual graph records the content. So it's supposed to look like this. Did I get that right? Likely no, because I don't know how to read Sparkle. Let's go. Oh no, I did get it right. Oh no, it says subject, not content. Right. Because the way that this should be read is, so how do you read this properly? So this is read as, get me the subject who has a relationship with this name, right? Like, so this is an RDF triple. This is the subject, the predicate, and then the, what do you call it? The object, right? Or the value. And basically saying, get me all subjects. And for that subject, when they have a relationship called name, bind that value to name here, right? So that's why it's able to get the name. So for that subject, find that relationship with the content, bind it to content. And for that subject, it should be of type pages. So if when we run this, it should work now. Stored query not found pages. Sorry. There we go. Content. There we go. Direction is yours. You get to decide what your direction is. Okay, excellent. Save that. Keep going. That is amazing. Okay.
Relational system with the IRIs generated based on the template we have defined, like artist 1, 2, 3, 4. These are the members of the Beatles band, and the names for the artists have also been retrieved. So as you can see, when you write these queries and execute them, it's as if all the data is stored in RDF format. But what happens behind the scenes, and we can see this a little bit by looking at the plan generated by Stardog, you'll see that this query plan actually shows you the SQL query Stardog automatically generated.
Interesting. So there's some translation going on. Show plan. Text. Virtual graph tome GG dev. This is number 1. So there's a node, a logical sort of fetching 1000, logical projection from ID 0, name, content 0 to 3. So I think that's the columns 0 to 3. Ooh, I'm right. Okay. And then logical filter, the condition, the third is not null, where the content is not null. JDBC table scan with this table, public pages, query, select ID, name, content, ID, name, content from that where the content is not null. Fetch the next 1000 rows only. Variables, bind the template of the ID. The name is a string, the content is a string. This is number 1, and this is number 1. Okay. That's curious. All right.
Based on your input query and the mappings you declared. So that's the kind of power of the declarative mappings. We can, looking at those mappings, we can reason about them and write these kind of queries that will retrieve the data we need from the relational system on demand. And we can use more complicated Sparkle features. For example, this query is getting all the albums, their dates, applying a Sparkle function to get the year component from those dates, then grouping the albums by the year they were released in, and then counting how many albums exist in each year. And you'll notice that in this query, instead of the graph keyword, we are using the from keyword, which is another way in Sparkle to define the input name graph. So you can use the virtual graph IRI in either of those keywords. So when we run this query, we get the results again. So since we have only 3 albums that we populated our tables with, we get 1 album for each of these years.
I think there's nothing else that I actually want to watch from this video. I think I'm good with that. So I was able to do what I wanted to do, which was be able to display the results from my database. This means that I can continue to create content on my Postgre. I can build applications that adds data into that Postgre. Yeah. Okay. So where are we now? So this is tome.gg. Okay, so let's kind of shift gears a little bit. Let's try to analyze where tome.gg is currently. So things that I've changed so far in tome.gg is we've focused more on a problem, goal, or scenario based kind of query approach, right? Like that's what we want to accomplish with this knowledge graph. We're going to be collecting different kinds of problems, goals, and scenarios and such. And what we're going to do is we are going to reference the related material. So I probably want to go to my Hasura cloud first. So let's just put this away while I log in. Okay. So I'm using Hasura Cloud, and that's free. Unfortunately, the servers are located in US West, North Carolina, which is unfortunate because I really wanted to be in Singapore. Singapore. Eh, eh, eh. Okay. So we have Hasura Cloud. Okay. We can probably go back. So we have Hasura now. We're gonna hide that away. So we have this data. Mhm. So this is version 2.15. Wow, it's a lot of updates. Um, Prettify query, merge query. Right. Oh, that's interesting. So what I want to do is I want to actually have um, oh, okay. So we're gonna need to fix this first. I'm gonna put this away. We'll go back and then we shall fix this. Just some password stuff. We'll be done with this in a bit. Here we go. Update connection. Check the database. There we go. Now we're all good. Oh, hi. I'm just gonna close all of the sensitive stuff. Okay, let's go back. Okay. So now we're back on Hasura and we have pages and pages, right? Pages, page states, etc. Filters, what's this? Oh, oh, it's a revised kind of oh my gosh, that is cool. Okay, so they revised how to access stuff here on filters and sorting. Okay, run data, export data, try GraphQL, subscription, live query, streaming. Okay, so what I want to do is I want to go to public and I want to create a table because I want to be able to hold on to goals, problems, and scenarios. So what are goals, problems, and scenarios? I think goals, problems, and scenarios, they are um, mm, I think we'll call them contexts, right? Contexts. Contexts are either problems, goals, or scenarios, or descriptive information that ties into some mental model, right? So we'll just put ID. We'll use UID, and then we'll use version 4. So it's gonna have a name, which is a text. It's gonna have a summary text, and then so we'll have a truncated content and the summary. This is nullable. So we're eventually we can build out a parser that goes to people's websites and then adds that as so the long-term plan here is I'm gonna build a scraper that goes on Reddit that looks for computer science related stuff and then automatically populates it um, into here. So we'll put external reference and then this will just be a URL. This is going to be a URL. Cannot be, it's nullable and it should be unique, right? It should be unique, right? Because it's a context. The context is unique. Yes, that's right. Truncated contents, yeah. No, yeah. ID, yeah. Okay, and then we'll just have created at. So instead of actually writing the created at manually, we're gonna just automatically generate them here. Updated at, deleted at, timestamp without time zone. And then deleted at is nullable. There we go. The primary key is ID. Unique key is external reference. Yes, it has to be unique, right? Check constraints. Yeah, this looks good. Right. Okay. Add table. Let's go. So the example that I was saying a while ago is, let's say you go to Reddit and then CS career questions. I feel like this is a very popular Reddit. So how popular is it? Reddit analytics. So let's see. I want to know how popular a certain thing is. Because I want to see how much traffic it actually has. No, this is not. Reddit, no, not user profile. Subreddit analytics. Snoop Sue. Is this paid? We'll see. Later for Reddit. Snoop. This doesn't sound like a safe website, to be honest. Reddit post management. Schedule your posts. Nope, this isn't what I need. Reddit metrics. I think it's this one. Okay. How is it not there? Subreddit stats. Oh, hi. There we go. Get stats. Ta-da! Okay, CS career questions. A subreddit for those with questions about working in the tech industry or in computer science related job. Right? There's almost 1 million subscribers. Comments per day 833, so it's quite active, I guess. Let's look at something for comparison. So Dota 2. that's the two data sources we'll be looking at, right? Okay. So comments per day is 833, comments per day is 3.6k, right? Posts per day is 80, posts per day is 400. Okay, so Dota 2 is really, it's actually bigger subscriber range. But okay, I'm actually surprised. I was expecting Dota to be less active than CS career questions. So top submissions, Elon Musk just asked when it's physically impossible, right? And then the subscriber count, right? Just nearing the million count, right? Subscriber rank, lower is better, right? So it's this one is like just really low. Okay, comments per day, ranging in the 1,000 to 1.5. This one's ranging in the 5,000 to averaging 2.5, right? 2,000, 4,000, 5,000, averaging 5,000, averaging 5,000 posts. Comments per day, posts per day. Okay, interesting. Okay, so the goal is, right? The goal is, I'm gonna build a crawler that goes on Reddit to look at these kinds of things, right? And these are scenarios, these are situations, contexts, right? And what it's gonna do is it's gonna automatically populate entries here into contexts. And then I'm gonna go ahead and create context states as well. Let's go to public, create a table called context states. Captures the different states of a context. Example, for review, right? Captures the different states of context. Yeah, I think that's fine. Then we're gonna have an ID, UID. Version 4, we're going to have value. So this is text. Let's just follow the same convention that I'm used to. So we're gonna have two fields here. It should both be non-nullable, and then create, so details, if we have something we want to store, this is nullable. And then created at, updated at, deleted at is active, right? Boolean. And then created at, updated at, deleted at. There we go. Okay, primary key is ID. Um, it's gonna need to reference a context. That's what I missed. Um, so we'll just put it here at the bottom. Uh, Context ID, which is a UUID. And we're gonna go foreign key under public. It's referencing contexts, and context ID references the context ID. And update violation, no action, on delete, restrict. Okay. Do I have enum here? Yeah, okay. A table. So what are the possible context states that we have? No, you know what? We'll just have that offloaded. We don't have to make it too strongly typed. This is fine. Just keep it simple. So we have context and we have context states. So what's going to happen is I'm going to have a bot, or I'm going to do it manually, where I read certain situations here. My remote colleague keeps leaving work for an hour or two each day, and it's impacting work during here. Should I tell the product owner? You do your testing, you leave him, or if their testing doesn't get done, it's not on you. Okay, this looks good. Yeah. So this is going to be my data set, actually. Mm-hmm. 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 Yeah. So what would be the most valuable thing that I should be doing? I think the most valuable thing that I should be doing is um, reading and writing. Simple solution, just read and write, read and write. So how do I amplify my reading? I can just go through it manually, honestly. Just get it running, right? Like if I read probably 5-10 Reddit posts a day, and then catalog them into Hasura, that would be good. That would be good. So I can build an app smith. Okay, so let's write down our goals, right? Um, where do we write our goals? Let's just fix this up a bit. Okay, so we're back. So the plan is, number one, we are going to read a lot of RCS career questions, right? Content, right? Determine, uh, observe patterns that already line up with dome.gg. Where do we put the associations? Right. So this is a good question, because right now we are actually writing tome.gg manually on this portal. But it would be a lot better if Um, right. So the visualization is on observable HQ. So this can actually be the different kinds of contexts, and then it's relating to a certain mental model that we already have, right? Mm-hmm. And then this data can be fetched from Hasura, right? Mm-hmm. So we're gonna have these contexts, right? Pages. Mm-hmm. Yeah, I think the pages just has to be finalized a bit. Mm-hmm. Right. So we're gonna be. These are basically the pages, right? Know yourself, don't carry rocks. These are the pages. Mm-hmm. And then yeah, that's okay. So let's put that. Let's answer that question, right? Where do we put that? So question, answer, right? Um, all data has to be stored in a structured uh, relational database so that it also has its corresponding um, can be reasoned with later on the knowledge graph, right? On Hasura Cloud, right? Should be stored on Hasura Cloud. Mhm. Okay, that looks good. Um, observe and record patterns that line up with existing tome.gg content, right? Alternatively, if the patterns do not exist as tome.gg content, um, earmark work in progress page on tome.gg. Diba? Thus, observe patterns. If the observe patterns in the context, if the pattern lines up neatly with existing, write down the relationship on Hasura, right? Mm-hmm. Mm-hmm. Okay. Mm, metrics. Goal. Um, write 1 to 2 new mental models per week. So this is average. Um, read up to 10 different CS career questions per day. Oh, maybe 15. Write down associations on Hasura Club, right? How might I make writing down associations on Hasura simpler? Um, so we can actually do this right now, right? Um, go. Okay, where do we put How am I gonna? We'll build a simple AppSmith low-code solution using AppSmith to add to link mental models to contexts. Right. Ideally, AppSmith loads the contexts from the pages itself. So this means we also need to do um, data cleaning on app.tome.gg database, i.e. Lift data from tome.gg. So that's, I guess, a question for myself. The question is, what do I keep in the database and what do I keep here? So if this is the source code, the database should just reference it, right? It's just a short reference, right? It should just be a short reference. Right. Okay. So it's likely gonna have its own under platform types. We should add another one called tome, right? Tome content exists as a page on tome. Save. Reload. So what that means is now I can reference its own content on tome. This makes sense. Still inconsistent. There we go. Let's go back. No more inconsistency. No? I'm still not happy. Just reload everything. No. I'm just gonna hard refresh, see what happens. Because it just might be a cache on the JavaScript on the client side, right? Nope. You have been redirected because your GraphQL engine metadata is inconsistent. Inconsistent object type platform types. Platform types is not tracked. Why is it not tracked? Okay. Track all. Okay. Go back. Reload all database. We don't have remote schemas. Reload. Okay. Metadata reloaded. It's not valid. Okay. Inconsistent object patterns. Yep. Okay. Fine. Let's go back because it's not a valid GraphQL. Please don't error. Oh shoot. Okay. It's fine. It's fine. I have access to pgadmin. Let's just change it here. Refresh. Platform types. View all. And then we'll call this one tome. Right. Where's the save button? Save data changes. Right. Let's go back here. Refresh. had a feeling that tome.gg wouldn't work. Apparently, I am right. Okay. 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 We're good. We're good, G. Okay. Okay. So again, product planning. I need to clean up the database so that it lists from docs. So we can actually do that right now, right? We can do that right now. Yes, let's do that right to now. Okay. So where is my Hasura? There we go. Insert a row. So this is under tome GG, and this is know yourself. Know yourself. This is the, I guess, the summary of the content. External reference is this one. We'll keep this one null. I think that's it, right? That's it. Not null. Null value. So we'll just leave it as an empty object. There we go. So we're done with this one. Don't carry rocks. Insert again. Use the right tool for the right problem. I'm trying to make a consistent kind of um, a consistent naming for my mental models. They're all very action oriented, so verbs on the, they're verb phrases basically. I don't have an entry for qualifier confidence levels. So we'll probably call it speak truthfully and precisely. Right? That sounds like a good call to action. Edit. There we go. Go. Added page description to mental models. Right. Just double checking if everything does have you have the power to not only change yourself but also your environment. Master yourself intense mastery of oneself can be limited or amplified by your environment. That looks like good context there. Okay, this one, know to be understood. You have to know who will do the understand. To be understood. Connect with your audience. To be for your message to be clear, you need to know For your message to be clear, for you to be understood, you need to know who is doing the understanding and what they know and don't know so far. Okay. Not all problems are solved. So minimize rather than maximize. Um, rather spend.
Hey, what's up, my guy?
Hey, that's curious. I heard it again. Where was that from? Where was that from? I heard myself say, "Hey, what's up, my guy?" Where did that come from? That is so curious, dude. This is not the first time this happened, and it always freaks me out when that happens. I don't know. Oh well. Back to work. Um, what are we doing? I'm gonna close that one. We're doing this one, I think. Um, sometimes fixing a leaky faucet. Minimize rather than maximize. Inverting your perspective on a problem gives you a fresh. Okay. So where were we? We were in Hasura. We were doing qualifier confidence levels, and we are here. Speak truthfully and precisely. Right. Okay. Let's go to terraform your environment. Let's go connect with your audience. And then minimize rather than maximize. There we go. Those are all of the new pages. So we're done with this one, right? Oh, I locked my screen. That was not what I wanted to do. How do I open emoji windows? Windows and period. So check mark. Right. Okay. Set data on tone.gg to accepted. Right. So this is AppSmith, the AppSmith part. Right. So we'll just log in again. So we'll just change a little bit. Okay, so we are here. Now we have all of these new ones, and we are going to approve all of them. So we go to unapproved pages and know yourself. So we're gonna approve that one. Right? Don't carry rocks, approve that one. Use the right tool. Qualify. Terraform. Connect. And minimize. Okay, we are good. So if I go to Hasura now, and then I check for other pages, know yourself, if I go to this page states, I'll see that it has been approved, right? Approved. Excellent. Okay, great. Now, if I understand correctly, then I can actually go to Stardog. ¿Dónde está? Where's the Stardog studio? There we go. How do I do relationships? Huh, how do I do relationships? How do I do relationships? Okay, virtual graphs. Page states. So I need to find the page state for a certain subject, right? So we're gonna make a new one. How do I make a new query? gonna copy it, and then we're gonna store this query and call it view approved pages or query approved pages, right? So if I run this, it's still all of the pages, but that's not what I want. I want to get the only ones which are approved. So we can do get me the name, get me the content, subject, pages. But how do I say that there's a relationship between a subject and a thing? Ref page ID? What's that? Ref page ID? Oh, it's a ref. Oh, okay. Huh? Okay. Okay. That's ref page ID. So this is the relationship, right? Okay. So we're gonna copy that one. We're gonna go back to our query. We're gonna go to query pages, where the subject, it's not a subject, right? So I'm gonna need the ID. So let's get the ID of the subject for pages. ¿Dónde está ID? This one. So we go back here. We go back here. This is now page ID, and then this is states, right? Where the states page ID is equal to the page ID, which is that one, right? Okay, so there's a set of states whose page ID is there, and then I need to see what it's like to view the is active boolean. Is active boolean, xsd boolean, xsd boolean, xsd boolean. So states the boolean. Sparkle xsd boolean true. So I need an example. Why is W3 not loading? I'm very curious. Right? Okay, I don't know what I'm doing. So this is the state has an is active flag of boolean. Is active. Then how do I say only get me the active ones? Then it would actually be the value here, I think. So true. I think it's that one. Let's see. It's gonna say wrong. It's wrong, right? Oh, it's correct, I think. I don't want to see the content first. I want to see the name. Save. I think I edited the wrong thing, so we're just gonna overwrite it, put it in the right places. Save. Okay. Go back to virtual graphs. Save this one. Hold me in your arms, babe. So this is the binding, right? So okay. We're not trying to go for perfect. This is fine. So let's go back here. So this is the subject, right? Right. And then the content. So we can run this again. So it has the subject, the name, the content, the states. There we go. Timing is essential, and then this is the state, right? Alright. So if we're gonna fix the thing, at least make it into this kind of binding. The pages is to this one. There we go. Pages, states. Okay, save. Go back here. On this one. It's correct now. Okay. This is for all pages, but if we run this one, looks good now, name. You get to decide what to do. So we'll call this one platform types. GG. I think this is fine. I did something wrong. Is it platform underscore types? Platform. Pages platform. Pages platform. Bang. There we go. This is our query, boys. Know yourself. If you find yourself repeatedly, Okay, content. I don't want the state, but I want to see the external reference. Right. And this is external reference. Save. Okay, we are good to go. This looks good. Okay, we did a lot of good progress today. We're able to start off with our knowledge graph. We were able to connect our database, which we worked on months ago, and it's now connected to our knowledge graph, which means we also have our content creation platform. So this is all very, very Gucci. Yeah. I'm gonna need to add additional pages. That's the next thing here, right? So this is also done. Create a new AppSmith page for creating associations on tome.gg. Relationships, associations in tome.gg. So yeah, that sounds good. I'm gonna end the channel with that. I feel like that was good progress in the span of what, an hour and 30 minutes? Pretty good. So we listened a little bit. We were able to put together quite a few things, um, kind of setting up the routine that I want to build for myself about reading and writing. Right, that's my mantra: read and write, read and write. So we'll do that, and I'm quite happy. I'm quite happy. I'm gonna go ahead and like dump these kinds of analytics here, right? Um, Analytics. So I'm just gonna show you what I'm doing right now. So analytics. So there is CS career questions. We also had Dota 2, right? And I guess I'm just gonna like copy that. I'm gonna go here. Just slap this one on here. There we go. Copy that. And then slap it on right here. Pretty good. So I feel like I'm being strategic. Um, Trying my best to say no to the itches to actually build things that I might not actually need. So I'm really just centering and focusing on the content, right? Because if this is really as valuable as I think it is, which I do think it is, um, then the content will speak for itself. Um, that's what I hope. Yeah. Mm-hmm. 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 Yeah, maybe I can talk a little bit about what I dream for this, right? So I just love games, dude. I just love playing games. And there's so much that we learn from games that we can apply to life, right? Like there's the whole kind of like table tennis is just tennis except it's smaller, right? Or baseball and golf are the same. You hit the ball, except golf it's not moving, right? There's these variations, but then these kinds of abstractions or simplifications immediately convey information, and tome.gg will be that highway, right? It will be that highway of easily being able to transfer knowledge from one domain to the next. And we're going to be focusing heavily on Dota 2, transferring that into software engineering. Um, yeah. Um, they're all going to be very interesting to observe from a visual aspect, but I still need to strategize about how I want to visually and auditorily present it. Um, I've been building content on TikTok, and people watch it. People watch me play my um, my Archon games. Yeah, my Archon games. And yeah, I just haven't been able to play a lot because my internet got completely disconnected since we moved in to our new place. But now I'm back. I'm able to spend a bit more time with with this and playing games. Yeah. I have been playing Zomboid offline because that's the only thing I could do while waiting for internet. I do have some friends that I've been playing um, Zomboid with on a server. Um, so yeah, if you're down to survive a zombie apocalypse with me, join our Discord channel, um, and let's play. But for now, I think we'll end there. And thank you so much for joining me. Bye bye.